Hi and welcome to Unit 2, Topic 2, Video 7. And in this video, we're going to talk about basic trig identities. And it's really probably the main purpose of this topic is to get towards the trig identities. It's the new thing and it's really the specialist specific thing. So we've got some learning goals, success criteria there, as you would expect. So, first of all, I'll just zoom out so we can see, well, I think that goes on for a while. Recall that sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan. Also, and we've talked about this in previous videos, tan is sine over cos, and sine squared plus cos squared equals 1. I've left out the thetas because I'm just a bit lazy. But there is, straight away, 5 identities. And remember we talked about the unit circle and how that related. In my lessons last week, on these videos, I have no idea when you watched it. So have a review of that. Go back to those previous videos if you need to. This comes up in video 4 and this comes up, I believe, in video 1. So this leads naturally to a couple of things. Firstly, cot is equal to cos over sine. So, and this is where we start our work on trig identities. We know that cot is equal to 1 over tan. That's our most basic level identity. That's the definition of cot. And so that means it's equal to 1 over sine theta over cos theta. I didn't need to put those brackets there because I wanted the brackets there. And so that means we're reciprocating that. So it's equal to cos theta over sine theta. If you like, when we divide by a fraction, we multiply by its reciprocal. That's another way to get that out. And now we've got 2 more identities down here. Number 2, which will take our identity list up to 8. But you don't need to memorize all these, and some of them are on the formula sheet, which we'll reference in a minute. So this leads naturally to these. Let's start with, we'll call this one A. If we have cos squared theta plus sine squared theta equals 1, that's our Pythagorean identity from up here. I've just flipped the cos and the sine around. And then we divide the whole thing by cos squared theta. Then this becomes cos over cos squared theta and over cos squared theta. Then we get 1 plus sine squared theta over cos squared theta equals, hopefully you can see this is sec squared theta. And that becomes 1 plus tan squared theta equals sec squared theta. Okay, so that's A, and we've got a proof of where that identity comes from. And then equally, if we take cos squared theta plus sine squared theta equals 1, and we divide by sine squared theta, now we get cos squared theta over sine squared theta plus 1 equals cosec squared theta. And that gives us cot squared theta plus 1 equals cosec squared theta. Okay, so there's our second identity, which I guess I'm intending to call B, just for reference purposes. So that's interesting where they come from and really helpful to see that we've got those 8, and they're so easy to get, so you don't even really need to memorize them. They're just so easy to build up. So let's have a look at a couple of examples. In fact, we're just going to do the one example and then I'll split this video in half. So this is a really particular type of example and there's a couple of ways of doing it. And so I'm going to show you both ways of doing it, 2 options. So here's option A, or option 1. In option 1, we go looking for an identity that relates cot and sine. Now keep in mind, if I can't find an identity that relates cot and sine, I could still find an identity that relates tan to sine or cot to cosec. Or worst case scenario, can I find an identity that relates tan to cosec? If I can do that, because I've got a direct relationship between tan and cot and sine and cosec. Now tan and sine are related, but there's a cos in there as well in that relationship. But what I do have is this one. Cot squared theta plus 1 is equal to cosec squared theta. So that one's from earlier. So I'm going to use my cot squared theta, and that gives me 5 over 12 squared plus 1 is equal to cosec squared theta. And so that's 25 over 144 plus 144 over 144. You'd have a calculator now probably, although there is a tech-free exam, and you could certainly do this in a tech-free exam, because this is 169 over 144. And we take the square root of that, we get 13 over 12 equals cosec theta. But remember, cosec theta is 1 over sine theta. And so now if we reciprocate both sides, we get sine theta is equal to 12 over 13. That's option 1, and it's the option I'd start to lean towards. But there are some questions that will lead nicely to option 2 as well. And option 2 is to say, well, if cot theta is equal to 5 over 12, well, then this means that tan theta is equal to 12 over 5. And that means that if I draw a right angled triangle, it doesn't matter about the size of this, because remember 12 over 5 is just a ratio. Well, in this particular right angled triangle, if that's theta and tan theta is opposite over adjacent, I get 12 and 5. Now you can see my scale's terrible, but that's okay. 12 and 5 there. I do a little bit of Pythag, and I get x squared is equal to 12 squared plus 5 squared, which is equal to 169, and therefore x equals 13. Notice here that we do start to get these common numbers popping up, 13 and 13, squaring 5 and 12 to get 169, for example. So there are things happening in common. But we get x equals 13, and that means that sine theta, which is equal to opposite over hypotenuse, is equal to 12 over 13. And would you believe it? Same answer. So there are a couple of ways of doing this, and they won't always both work, although they often will. But option 1 is the one that's going to lead you to better understanding for this topic. So I would certainly be considering that. Okay, well that's the end of this video. All the best.